Section 14.3, Quadratic Equations, the quadratic formula. The objectives: use the quadratic formula to solve quadratic equations. Use the discriminant to determine the nature of a quadratic equation's solutions. The quadratic formula for the general quadratic equation ax squared plus bx plus c equals 0, where a is not equal to 0, the solutions are x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. For convenience and without loss of generality, in the development of the quadratic formula and in the examples and exercises, the leading coefficient a is positive. If a is a negative number, we can multiply both sides of the equation by -1. This will make the leading coefficient positive without changing any solutions of the original equation. Example 1, solve by using the quadratic formula. X squared minus 5x plus 3 equals 0. For our solution, we substitute a equals 1, b equals -5, and c equals 3 into the formula. X equals opposite of b plus or minus square root b squared minus 4ac all over 2a, which is the opposite of -5 plus or minus the square root of -5 squared minus 4 times 1 times 3 over 2 times 1. That simplifies into 5 plus or minus the square root of 25 minus 12 all over 2, which is equal to 5 plus or minus the square root of 13 over 2. Example 2, solve by using the quadratic formula. 7x squared minus 2x plus 1 equals 0. For our solution, we substitute a equals 7, b equals -2, and c equals 1 into the formula. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's equal to the opposite of a -2 plus or minus the square root of -2 squared minus 4 times 7 times 1 all over 2 times 7. That equals 2 plus or minus the square root of 4 minus 28 all over 14. That's 2 plus or minus the square root of -24 all over 14. That simplifies into 2 plus or minus 2i square root of 6 over 14. Square root of -24, remember, will simplify into the square root of -1 times the square root of 4 times the square root of 6, which is where we get 2i square root of 6. Then we're going to reduce this, so we're going to factor out of a 2 in the numerator and denominator. That leaves me with 2 times 1 plus or minus I square root of 6 over 2 times 7. The 2's are going to divide out. That's going to leave me with 1 plus or minus I square root of 6 over 7. Or in standard form, 1 over 7 plus or minus the square root of 6 over 7i. The solutions here are non-real complex conjugates. Example 3, solve by using the quadratic formula. 3/4 x squared minus 1/2 x equals 1/3. For our solution, the quadratic formula is easier to use if we have integer coefficients. So we're going to multiply every term by the lowest common denominator, or LCD, in this case 12, so that the coefficients will be integers. So I take 12 times 3/4 x squared minus 12 times 1/2 x equaling 12 times 1/3. That gives me 9x squared minus 6x equal 4. Now I'm going to set it equal to 0, so that's 9x squared minus 6x minus 4 equals 0. Putting this into the quadratic formula where a is 9, b is -6, and c is -4, we have x equals the opposite of -6 plus or minus the square root of -6 squared minus 4 times 9 times -4 all over 2 times 9, which is 6 plus or minus the square root of 36 plus 144 all over 18, which is equal to 6 plus or minus the square root of 180 over 18, which is 6 plus or minus 6 square root of 5 over 18. Factoring out a 6 from the numerator and denominator, we have 6 times 1 plus or minus the square root of 5 over 6 times 3. The 6's divide out. That leaves me with 1 plus or minus the square root of 5 over 3. Example 4, solve by using the quadratic formula. Here we have the quantity 3x minus 1 times the quantity x plus 2 equals 4x. So we're going to start by distributing on the left, which gives me 3x squared plus 5x minus 2 equals 4x. Now we're going to subtract 4x from both sides so we can set it equal to 0. That's 3x squared plus x minus 2 equals 0. Now a is equal to 3, b is 1, c is negative 2. Substituting into the quadratic formula, we have x equals the opposite of 1 plus or minus the square root of 1 squared minus 4 times 3 times negative 2 all over 2 times 3, which ends up giving us negative 1 plus or minus the square root of 25 over 6, which is negative 1 plus or minus 5 over 6. So if we look at negative 1 plus 5 over 6, that ends up giving us 4 over 6 or 2 over 3. And then we look at x equaling negative 1 minus 5 over 6, which gives us negative 6 over 6, which is negative 1. Whenever we have solutions that are rational numbers, the equation can be solved by factoring. In this example, we could have solved as follows. 3x squared plus x minus 2 equals 0. That would have factored into 3x minus 2, that quantity, times x plus 1, that quantity, equaling 0. I would set 3x minus 2 equal to 0 and solve that, and x plus 1 equal to 0 and solve that. So 3x minus 2, when I solve that for 0, I would add, when I solve that for x, I would add 2 and divide by 3, which gives me x equals 2/3. X plus 1 equals 0. I'm going to subtract 1 from both sides, which is going to give me x equals negative 1. So the quadratic formula always works, no matter what kind of solution we have. But a lot of times factoring is easier, so always look to see if you can factor first. One of the common errors that students often make is when you simplify fractions, when you're dividing the denominator into only one of the terms in your numerator, that's when a lot of students make a mistake. So you can see there the information they have crossed out in red. You had 4 plus 2 square root of 3 over 2. And all they divided out on that part of the problem were the 2's here. So they thought the solution was 4 plus the square root of 3. Your correct solution, and you could have done this either way, we could have taken 4 plus 2 square root of 3 over 2, rewritten it so it was equal to 4 over 2 plus 2/3 over 2, and then the 4 over 2 would have reduced to 2. Those 2's would have divided out, and I would have been left with plus the square root of 3. Or this second green box is what we did in those first examples. So we had 4 plus 2 square root of 3 over 2, factor out a 2 in my numerator and a 2 in my denominator. So factoring the 2 out of my numerator left me with 2 plus the square root of 3. The 2's on the outside divide out, so my solution was 2 plus the square root of 3. Example 5. Solve the following cubic equation by factoring and using the quadratic formula. 2x cubed minus 10x squared plus 6x equals 0. For our solution here, the first thing we're going to do is take out our greatest common factor, which is 2x. That leaves me with x squared minus 5x plus 3. Now I'm going to factor that trinomial. So I've got the 2x equals 0, that's one of my factors, and then x squared minus 5x plus 3 equal to 0. And I'm going to factor that x squared minus 5x plus 3, or use the quadratic formula. 2x equals 0. We're going to divide both sides by 2, so x is equal to 0. If I can't find two things that multiply together to give me 3 and add to give me negative 5, I have to use the quadratic formula, so that's what I'm going to do here. That ends up being x equals 5 plus or minus the square root of 13 over 2. So there are three solutions to this cubic equation: 0, 5 plus the square root of 13 over 2, and 5 minus the square root of 13 over 2. The discriminant is the part that's under the radical in the quadratic formula. So it's the b squared minus 4ac. That's the discriminant. If b squared minus 4ac is greater than 0, which is a positive number, there are two real solutions. If the discriminant, which is b squared minus 4ac, is equal to 0, then you're only going to have one solution, which is going to be the opposite of b over 2a. And then finally, if b squared minus 4ac is less than 0, or a negative number, you're going to have two non-real solutions. Example 6, find the discriminant and determine the nature of the solutions to each of the following quadratic equations. 6a is 3x squared plus 11x minus 7 equals 0. So a is 3, b is 11, and c is negative 7. If I plug that into the discriminant, b squared minus 4ac, I end up with 11 squared minus 4 times 3 times negative 7, which is 121 plus 84, which is 205, which is greater than 0, or a positive number, which means they're going to have two real solutions. 6b, we have x squared plus 6x plus 9 equals 0. A is 1, b is 6, c is 9. Our discriminant, b squared minus 4ac, is 6 squared minus 4 times 1 times 9, which is 36 minus 36, which is 0, which means we have one real solution, and it's a double root. Example 6c, x squared plus 1 equals 0. Here b is 0, but we could write it as x squared plus 0x plus 1 equals 0. But b squared minus 4ac is going to give us 0 squared minus 4 times 1 times 1, which is 0 minus 4, which is negative 4. That means there's two non-real solutions because that number is less than 0. Example 7, determine the value or values for c such that x squared plus 8x plus c is equal to 0. We'll have one real solution. The hint here, set the discriminant equal to 0 and solve the equation for c. So we have b squared minus 4ac equals 0. Plugging in what we know, 8 squared minus 4 times 1 times c equals 0, which is 64 minus 4c equals 0. Subtracting 64 from both sides, we end up with negative 4c equals negative 64. Dividing both sides by negative 4, c is equal to 16. So we can check that to see if it really does end up giving me one real solution. X squared plus 8x plus 16 equals 0, which is x plus 4, that quantity squared, which means x is equal to negative 4. There's only one real solution, thus negative 4 is a double root. Example 8. Determine the value or values for a such that ax squared minus 8x plus 4 equals 0 will have two non-real solutions. Your hint, set the discriminant less than 0 and solve for a. So for our solution, we're going to have b squared minus 4ac is less than 0. Plug in what we know. Negative 8 squared minus 4 times a times 4 is less than 0. 64 minus 16a is less than 0. Subtracting 64 from both sides, we have negative 16a is less than negative 64. We're going to divide both sides by negative 16, which means we're flipping the symbol around. So we end up with a is greater than 4. Thus, if a is any real number greater than 4, the discriminant will be negative and the equation will have two non-real solutions.